In this section you will learn about loops. Loops are very common, in particular when you write models, because loops are useful always when we want to do the same thing over and over again. And this is something where computers are incredibly good at. Whenever you write an agent-based model, for example, and usually there are a lot of different time steps, and in every time step the same procedure is implemented. To implement this, we are usually using loops, so it's very important to know about them. Here we will basically learn about two different types of loops. On the one hand, we have the for loops. They take an input container and iterate about the individual elements of them. So you could think about a for loop taking a list of numbers as an input and take the square root of every number. On the other hand, we will learn about while loops. While loops work like this. You set a condition and you repeat a certain action until this condition is met. For example, you want to approximate a certain number by implementing a certain procedure, and you want to you set a condition which specifies an error margin, and you approximate the number better and better until the error is sufficiently small. To implement something like this, you would use a while loop. Then, in the end, we will learn something that is very particular for the Python programming language. It is called a list comprehension, and it's basically a way to implement for loops in a more readable and in a more efficient way. But first of all, we will start with the for loops. We will now learn how to implement for loops in Python. A for loop takes a container as an input, or more specifically an iterator, a data type we will learn about later, and it operates on the elements of this iterator. Now, a common task here could be to take a list from the numbers from 0 to 10 and to create a new list with the square roots of these numbers. And to do this, we can actually use a loop. The first step is actually to create this list, and in this case, the range function comes in handy. We can use the range function to create a list from 0 to 10 like this. The range function produces a particular iterator that starts from 0 and goes until the first argument -1, so it returns an iterator of the length that is indicated here. And if we transform this object into a list with the list function, we get exactly what we want. To write a for loop, we have to tell Python we are writing a for loop by using the keyword for. We then need to provide Python with a particular keyword, and this keyword is almost arbitrary. It is common to use the keyword or the index I. Then this is followed by the keyword in, and now we have to specify the input container. In our case, this is xlist. Then we end with a colon, we press enter. It is very important to keep track of the right indentation here. And now we describe the action that actually makes up the for loop. Now what we want to do is that for every element in xlist we want to have the square root. In the first step we might just want to print it. And to get the square root we already know that we have to raise the element to the power of 1/2. If we execute this, Python goes through the xlist, and for every element in the xlist it prints the square root. Let's see how that works. So here you see that actually for the first element in xlist, which is 0, the square root of 0 is 0. For the second element, the square root is 1. For the third element, the square root is 1.414, and so on. And this is actually how a for loop works. Now, here we have only printed the results, but since we want to store them in a list, there are a number of ways to do that. One common way is to first define an empty list, and then in every step of the procedure here, append the result of this operation to the new list. To do this, we can use the method append we have already learned about before. If we execute all this, we actually see here that we have now produced a new list via square roots with all the square roots of the initial list. This is how a basic for loop works. While this is useful to understand how basic for loops work, it is usually better not to work through the single elements of a list, but through the indices of the list. To see why, we want to consider the following example, which is also explained in the script. Now suppose we have these three lists and we want to write a for loop that operates on all three lists. We can do this by looping through the elements of the lists like this. Now, as you see shortly, this won't work. Python gives an error. List indices must be integers or slices, not strings. Now we see here that in the list 1 we have 3 strings, but here we actually we use the elements of the list as indices, and this obviously does not work. We could solve this problem by looping through the the elements of list 2, but it actually turns out that if we loop through the elements of list 2, it works for the first 2 times, but then the list index is out of range. Because remember that Python actually starts counting indices at 0 and not at 1. So we have to think about something else. And one solution to this problem is to loop through indices and not the elements. To do this, we add here the range function we just encountered. And we provide as an argument to the range function the length of the lists we want to loop through. Now, if we execute the code, everything works as desired. So this is a general lesson. Always think about whether it couldn't be better to loop through the indices of your input containers and not through the elements. Sometimes it's also better to loop through the elements, for example, if you want to call particular methods of them, but in the vast majority of cases, it's actually better to loop through the indices. There are 2 more things I want to tell you about for loops. The first thing is that this key value here is actually pretty arbitrary. So instead of I, we could also use something like blah. The only important thing is that you also have to replace it in the body of the for loop as well. Otherwise, Python will throw an error and ask you about what I is. If we execute all this, we see that it works exactly as before. Now, the second thing is that it is actually very useful and easy to combine for loops with the programming techniques we've learned about so far. To see this, consider the following task. Write a for loop that operates on the list of elements from 0 to 8, and for each element the for loop tests whether the element is even or odd. If the element is even, it should take the square root. If it is odd, it should take the second power of the element and store the results in the new list. You can actually try this out yourself. The only thing you need to know is how to test whether a number is even or odd in Python. To do this, you can actually make use of the modulo operator. The modulo operator is the percentage sign, and if you write 4 modulo 2, that gives you 0 because 4 divided by 2 is 2, and there is no remainder. However, if we write 3 modulo 2, we get a remainder of 1 because 3 divided by 2 is, 1 with a remainder of 1. You can use this, or you can implement this in an if-else statement and implement the test whether the modulo of an operation with 2 equals 0. If it equals 0, then we have an even number, otherwise the number is odd. You can try this out yourself, and if you don't want to, you can also just continue the video and we look at the solution. The first step is to create the list of elements, and we can do this by using the range function as before. So this is the list on which our for loop should operate. It is often a good practice to write these for loops piecewise. So first of all, we want to write a for loop that goes through the indices of the X list and just prints the elements. So we use the keyword for, we think about a keyword, and then we write in, and then we go through the indices of the X list. And we do this by using the range function and take as an input the length of the X list. We end the line with a colon, and now just to see whether we've done it correctly, we print the I for every iteration. Now let's see. We now actually see that this is exactly what we want. The for loop now goes through the indices of the list. Now we add here the X list so that it actually goes through the elements of the list. Now that still works, so we can actually continue to move towards the actual target. Now what the for loop should do, it should test whether the actual element is even or odd. So we need to add an if-else statement. We do this with the if keyword and then writing down the condition. Now we ask Python here whether the actual element of the X list is even by writing xlist I modulo 2, and we know that if the result of this operation equals 0, then we have an even element. In this case, we want to create a new value, and this new value should be the square root of the element in the X list. So in this case, we write xlist index I, and we take the square root of it by taking to the power of a half. Now we can already test whether this is true, and to check it, we can print the new value, and let's see whether this works. And this actually already makes a lot of sense, because here we see the list element 2 is even, so it should print the square root. The element 3 is not even, which means that Python does not enter the if statement here, but just ignores it and continues with the next element, which is 4. But here the condition is fulfilled, so Python enters the body of the if statement and prints out the square root of 4. So now we just need to add the else statement, and in this case we want the new value to be the element of the X list raised to the power of 2. Now all that needs to be done is actually to save these results in a new list. To this we create here an empty list, and then in each iteration we add the new value to this list, and we can do this by using the append method that we have encountered before. Now let's see whether this works. We see that this is actually working very well. So for 0, for 1 we have nothing, for 0 we have the square root, for 2 we have the square root, for 3 we have 3 to the power of 2, and so on. So here we actually completed the task by combining a for loop with an if-else statement. Now a common mistake that often happens here is that you get the indentations wrong. In this case here, what happens is that Python only appends the new value if you are here in the else statement, because these indentations for Python are very important. The dangerous thing in this case is that Python does not throw out an error. You are just wondering, if you look at the resulting Y list, that it only contains 4 elements, and this is because Python only appends something to the Y list if it is here in the else statement. This is actually an indication that you always have to be very careful about the indentations in Python.